an alternative to deriving the coefficients a, b, and c for the quadratic equation. The standard form equation for quadratics is y equals ax squared plus bx plus c. So here's a random quadratic equation. Here's the table for it, and here's the graph. I didn't provide the equation because I'm going to show you how you can use some laws about the coefficients that are always true to derive them. Now, as you know, the rule for the table is that there's a constant second difference in the outputs. So here I've worked that out below. The x values are increasing by a constant of positive 1, so that's an add. And then the y values, our output, don't have any constant in the first differences, but when I look at the differences of the first differences, in other words, the second difference, I find that there's a constant of positive 2. So it's add and then constant second difference. Now, here are the laws that are always true. 2a will always equal our answer for the second difference. In this case, it's a positive 2. I can set them equal to each other and derive a. Once I know a, I can plug into the second law that's true. 3a plus b will always equal y2 minus y1. y2 is going to be found on the table where x equals 2. y1 is going to be found on the table where x equals 1. And you must use those points. You cannot use any random consecutive y values. It has to be y2 where x equals 2 and y1 where x equals 1. Now I found b and a. The last law is a plus b plus c will always equal that y1 value where x equals 1. So here it is worked out with the table that I provided. And you want to do these laws in order of A, B, and C since it helps eliminate the terms. 2a equals the second difference. So I only have one variable here that's easy to plug in. 2a equals 2, and therefore a equals 1. The second law is 3a plus b equals y2 minus y1. I know a is 1, so I can plug that in. 3 times 1 plus b equals y2 minus y1. As said before, my y2 value is going to be found on the table where x equals 2. In this case, that is negative 4. My y1 value is going to be found in the table where x equals 1, and that is negative 6. So I have 3 plus b equals negative 4 minus negative 6. That's a double negative, so it'll be negative 4 plus 6. And that gives me 3 plus b equals 2. I'll have to subtract the 3 on both sides to get b by itself, and that gives me b equals negative 1. Now I know a and b, and I can get c by itself in our last law. A plus b plus c equals y1. I plug in for a, which is 1, and I plug in for b, which is negative 1. And 1 plus negative 1 will cancel, so I get c all by itself. C equals y1, and in this case, x equals 1. I go to my table, right across from it is negative 6, as said before. So c just equals negative 6. Now, we found all the coefficients, a, b, and c, and we just have to plug them into our standard formula. So y equals ax squared plus bx plus c. And when I plug that in, I get y equals x squared minus x minus 6. So now that I have an equation, I want to check and make sure that I have the right equation. So I'm going to type this y equals into my calculator and then pull up the table for it and make sure that the values are the same in the table that was provided as the one I pulled up on my calculator. So here I have a calculator. I typed in my formula that I derived, y equals x squared minus x minus 6. And now I'm going to look at the table for it. Negative 3, comma 6, negative 2, comma 0, negative 1, comma negative 4, and so on and so forth. It looks like I did it right, so I have the right equation. I hope that's an easier way to find A, B, and C. Let me know if you have any questions.